I've used the same news as the numerator 3, but I can't. The little packet that comes with it says you have to solve the middles of all sides.
Yeah.
That was hard.
All right, guys. So we're starting or picking up at this point here. So I know this is where we stopped yesterday for this problem here, but we're going to go on and move on from it because I feel like most of y'all have a good understanding of how to just simplify these at this point. Because we're simplifying like terms on top and bottom and reducing. Anything in common reduces. So, well, we can go on and do this here. So when we simplify this here, the first thing we really need to do is multiply the numerator with numerators, denominators with denominators, multiplying straight across. So we can say 3 times 6 is 18. X to the 5th times x. Like bases, we add the exponent, so that'd be x to the 6. And y squared times y squared would be y to the 4th. In the denominator, 8 times 9 is 72. X times x cubed would be x to the 4th. And y times y would be 2nd. Now at this point here, we can do 18 over 72. We can simplify that. Yes. Just water. Now, because when we have like bases, we add the exponent. So I have 5 of them being multiplied together. We have one more, so we have a total of. Now the first thing we can do is 18 over 72. So we can do that in a calculator, 18 over 72. Hit enter, it is 1/4. Almost. So we have 1 on top, and we can put 4 on bottom. I'm not going to write the 1 yet, just in case there is something left over on top. If everything simplifies out of the numerator, we can put the 1 back in. Now the next thing we'll look at is x to the 6th divided by x to the 4th. When we have like bases and we're dividing, we don't add the exponent, we're going to subtract. So we can say 6 minus 4, which is, if it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. Since x to the 6th was bigger, x is going to stay on top, it's going to be x squared. Because 4 of the ones on bottom will cancel out with 4 of the ones on top, which means we have 2 left over on top. We get this here. Y to the 4th over y squared. 4 minus 2 is, and it stays on. That's it. Yep. It's really building up to our simplifying rational expressions. So we're building off really something that y'all have done before. We've done these before. And now we're going to look at these here. These here are going to be very much the same thing, except now we are having to factor first. Because when we multiply these here, we could go on and multiply them together, but it's going to be easier to factor the numerators and denominators and then multiply them together. Now out of these 3 here, out of these 4, 3x is already as simplified as it gets. It's one term. There's nothing we can do to it. So we can just rewrite it in as 3x. Now we look at the other 3, the numerator 3x minus 3x squared. There is a greatest common factor between 3x and 3x squared, and it is 3 and x, because they both do have a single x and they both have 3, so we can factor it out. So if we factor 3x out of 3x, we have 1, guys. Let's focus up here. Minus the 3 out of 3x squared will factor out completely. We'll take 1x away from x squared, which leaves us with a single x. So we factor 3x out of 3x minus 3x squared, we get 1 minus x. Questions on this so far? All right. Now, it doesn't matter which one we do next. We can look at the denominator, which is our x squared plus 4x minus 5. Now, there's not a greatest common factor to pull out, so we can go on to our two sets of parentheses with three spaces. Since the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Now, the factors of x squared are x and x, so we can go on and fill that in. And the only factors of 5 are 1 and 5. So we need to figure out which one we want to be positive, which one negative. We can make the 5 positive and the 1 negative. Now, if we check this here, x times negative 1 is negative x. 5 times x is going to be plus 5x, which does give us a positive 4x, which is the middle term we wanted. So these are the correct factors. Now we can move over to the last one that we do need to factor, the x squared plus x minus 20. Since the 20 is negative, our third term is negative, our signs are going to be opposite. One's positive, one's negative. Factors of x squared are x and x. Now factors of 20 are 1 and 20, 10, 10, 4 and 5. Which one of these do we want to try first? 4 and 5. And the reason we're doing that is because we see in one of the denominators we do have x plus 5, yes?
Wait, what are we trying to get?
1x. So 4 and 5 would be the one we're trying first. Now, if something's going to simplify, we need it to be the same on top and bottom, yes? Well, on bottom, I already have n x plus 5. So if it worked out with 4 and 5 that 5 was the plus, 4 was the minus, I do now have an x plus 5 on top and bottom, yes? So that's one thing we can do is we can use what we already have factored to try to find the factors of the other so that something will simplify. And if we do check, x times negative 4 is negative 4x. Positive 5 times x is plus 5x, which gives us a single positive x. So that's what we wanted. So we can use some of those other factors to try to see what the others will factor to. Now, we multiply these together. Numerators with numerators, denominators with denominators. And whenever I multiply these here, if I have any monomial terms, one term, so here we have 3x on top and bottom, I try to move those to the front. All right, guys, focus. So here, 3x is already up front, but for the denominator, I'll move it up front. If we have that single term that's not in parentheses with addition subtraction, I normally move it to the front. On top, we also have our 1 minus x, our x plus 5, and our x minus 4, because they're all just being multiplied together, so more and less terms, we just squish them all together because that is being multiplied. The denominator will have a similar thing. We'll have x plus 5 and x minus 1. Do we have something in common on top and bottom? X plus 5 and x plus 5. Because x plus 5 divided by x plus 5 is 1, so they simplify out. 3x divided by 3x is 1. Anything divided by itself is 1, so it simplifies out. Or as we're used to saying, it cancels out. Now the x minus 1 and 1 minus x are very close to each other, yes? Anytime we have a set of parentheses where both terms on top and bottom are opposite each other. So here, we have positive 1 on top, we have negative 1 on bottom. We have positive or negative x on top, positive x on bottom, yes? If they're both opposite, we can pull a negative 1 out of one of them. Here, we can pull it out of the top. So I factor a negative 1 out of the top. And just the one of them. I'm not doing it with both, just the one. Because if we factor a negative 1 out of negative x, if I factor a negative away from a negative, it becomes positive. If I factor a negative away from a positive, it becomes negative, yes. We still have the x minus 4. Now do they match? If both signs of one are opposite of both signs of the other, then we can pull that negative out and they're going to match. If it had been x plus 1, it doesn't work. Because the plus 1 would become minus, but the x is now negative as well, so they don't match anymore. And let's see what that leaves us with. Well, we still have the x minus 4, but we also have the negative in front. So this whole thing simplifies to negative x minus 4. Or we can say negative x plus 4. But the only difference between those two is that I multiplied the negative through, giving us the other version. They're the same answer. Questions on this here? Now, one of the things we could have done, or note at the start, here it's the bigger power. So here the 3x squared, if it's negative, might as well pull the negative out. And we've been doing that, especially when we talked about factoring to begin with. When we dealt with the quadratic that had negative x squared or a negative in front of the x squared, we pulled the negative out to make it positive because we like the variable with the biggest exponent to be positive. It's easier to work with. Same with this here. So if we look at this next example here, the top one does have a negative 5x squared, yes? So that means when we factor it, we can go on and factor it, we can pull that negative out to make it positive from the beginning. So we don't have to get all the way to the end and say, okay, these are similar, we need to take that negative out now. Is there any other greatest common factors between 5x and 5x squared? Well, 5x, yes? So we can take it out. Now if we take 5x, because I'm going to flip it a little bit, because 5x out of 5x is what? Going to be 1, yes? And 5x out of 5x squared is going to be x. I like having the variable in front, so I'm flipping it and doing that all at once. Are we comfortable with that? Because negative 5x out of negative 5x squared, the negative 5 simplifies, x squared becomes x. Negative 5x out of 5x is 1, yes? But because it was positive, it is now negative. Any questions on this here? All right. We're ready to look at the one that was actually easier to factor than that. Yeah, well, 5x is 5x. That's as simplified as it gets. If there's only one term, we just put it back down because there's no way to simplify it further than that. Now we can look at the first denominator, the bottom of the first fraction, or x squared minus 4x plus 3. So since the 3 is positive, the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared are x and x. And the only factors of 3 are 1 and 3. Since they're both negative, we just throw them in. Now, last hour I had someone ask, well, we have the x minus 1 over x minus 1 already, yes? Can we simplify that? Yeah, anything divided by itself is 1. There's nothing saying that we have to wait till the very end once we multiply it to simplify. If we have something divided by itself, it will cancel itself out or simplify itself out to 1. Now we have our other one, the x squared minus 5x plus 6. There is no greatest common factor. But since the 6 is positive, our signs are the same and they match the sign of the middle term. Are negative and negative. Factors of x squared are x and x. Now factors of 6 are 1 and 6 or 2 and 3. Which one do we think is going to work? 2 and 3, because we do already have an x minus 3 there, so it'd be very helpful if we also have an x minus 3 on top. So those will cancel. Now, will that always be the case? No. But for a lot of the ones we're working with, because this is the type of problems we're solving, they're going to work this way. Yes?
That equals positive 5 over positive 5.
So our 5x over 5x?
The x minus 2 and x minus 8.
Yes.
That equals positive 5x, right?
So it'd be x times negative 3 is? Negative 2 times x is? Yeah. Any questions on this here? Any other questions so far? Now, in the last one, we rewrote it, yes? And really, what did we do? We just put all this stuff, the two numerators on the same line, yes? We put everything in the denominator underneath the same line, yes? Kind of like that. That's what we're going to do. It's instead of rewriting it again, I'm just connecting the two and saying that's what we're doing. We're multiplying. So this does work with multiplication. We can't do this with addition. We'd have to kind of rewrite it out and see how it looks, because addition's a little bit weird. But if rewriting it helps, rewrite it. Rewrite it as it reordered. Do that. If that helps, do that. If this makes more sense to you, do it this way. Whichever way is going to help you keep everything straight. Do we? Well, we have some few things left on top and bottom that are the same, yes? The x minus 3 and x minus 3, what else? The 5x and 5x, so what are we left with? Negative x minus 2. That's it. Any other questions on this here? We feel good with these so far. A lot of just factoring and then multiplying and simplifying. I'm going to go on to this one here because I feel like y'all are getting the hang of how these work. They're not too there's not a whole lot of steps to them. It's the basic same few steps over and over again, really relying on factoring. If we get factoring and are able to factor it and then multiply them together, this makes sense. So with this one here, we're going to start off with factoring these. So we have 4 different ones, 2 in the numerator, 2 in the denominator. Looking at the numerator, we have c to the third plus 8. Is c to the third a perfect cube? C to the third a perfect cube. What times itself 3 times is c to the third? C, because c times c times c is c to the third. So if we took the cubed root of c to the third, we would just get c. If we took the cubed root of 8, what is the cubed root of 8? 2. 2 times 2 is 4, times 2 is, so the cubed root of 8 is 2. And the reason I write that is kind of reiterating that c to the third plus 8 is a sum of 2 cubes for our factoring. So that means we can factor this as the sum of 2 cubes, which means we'll have a little parenthesis and our bigger one. Now, if we remember back to last week or the week before with doing these, we got what we call a linear term. So where we have a set of parentheses, 2 terms to the first power. And then we had a quadratic term. Is the other one. Our first term was something squared plus going through. And this here, this quadratic term, will not factor from a sum or difference of perfect cubes. Because when we first covered it, I reiterated it, I think at the beginning of the semester. The quadratic that comes out of this will not factor. Okay? So, if we do notice that one of them is going to be the sum or difference of perfect cubes, I would start there. Because there's a chance that I'm just going to pick c squared minus 2c plus 4 could be that quadratic that comes out of this sum of two cubes. And if it is, that means this thing here won't factor. So I wait on it, because I would rather get the cube done first, say, okay, that quadratic matches, I don't have to touch it, instead of spending way too long trying to figure out its factors, and turns out it doesn't factor. So let's deal with the sum of two cubes first. Now our signs are going to be the same, opposite, always end on a positive note. So since it's plus, so it's our same as plus, minus, plus. Well, the signs are lining up with the other one, yes? Minus, plus. Our first term here is going to be c. Here we're going to have c squared, c to the first, no c. Our other term is 2. So in here we'll have 2 to the first, and the last one is what? 2 squared, yes? What is 2 squared? 2 times 2 is 4. Do those two match? Yes. So what that tells us is that this here doesn't factor. You don't even have to mess with it, because the quadratic that comes out the sum or difference of perfect cubes will never factor. So that's good to know, because that one won't factor either. Questions on this so far? Let's look at the denominator of the first one. C to the fifth minus 4c cubed. Is there a greatest common factor between those two terms? Between these two terms here. C, what power? Because both of them have at least 3, so we can pull those out. If we factor a c to the third out of c to the fifth, we're left with c to the second minus 4. That's nice to see. Because we have subtraction of two terms, yes? Is c squared a perfect square? Well, yes, c times c. Is 4 a perfect square? So it's a difference of perfect squares. Those are the ones we like, because they factor nicely. Let's look at the numerator before we move on to factor that one. C to the sixth minus 4c to the fifth plus c to the fourth. 4c to the fourth does have a greatest common factor of c to the fourth. There's 4 of them in all 3. Let's pull it out before we do anything else. If I pull out c to the fourth from c to the sixth, we're left with c squared minus 4c plus 4. We're taking 4 of the c's away from each one, which gives us this here. Questions on this so far? Hopefully this is turning out to be a lot nicer than you thought this was to begin with, yes? And a lot of these here, again, they might look nasty or very difficult from the beginning, but tackle them one step at a time. Factor them one thing at a time. And as I said yesterday, figure out which one you can see to factor the easiest first, and then go from there. Because taking care of the sum of two cubes, let us know that c squared minus 2c plus 4 didn't have to be messed with. C plus 2, c squared minus 2c plus 4. Denominator c cubed. So now we can factor the c squared minus 4, which will factor 2. C plus 2 times c minus 2. Difference of perfect squares. Now, yes, at this point, if we wanted to say that the c plus 2 and c plus 2 cancel, divide by themselves, we can go on and cancel. Now, in the other numerator, c squared minus 4c plus 4. The 4 is positive, so our signs are the same, and they match the sign of the middle term, which is negative, negative. Factors of c squared are c and c. Factors of 4 are 1 and 4, or 2 and 2. which one we're going to use. Well, 2 and 2, yes, so we can have something match on top and bottom. So we have this here. Questions on this so far? Connect those together and let's simplify. Well, c squared minus 2c plus 4 will cancel with c squared minus 2c plus 4. Also, one of the c minus 2's will cancel with one of the c minus 2's, because only one of them will cancel with one. They won't cancel with both. Because since we have 2 of them on top and only 1 on bottom, only one of them will simplify. We'll still have 1 left over. And last but not least, c to the 4th over c to the 3rd. 4 minus 3, because they're on different sides. C to the 1st times c minus 2 is left on top, yes? Is anything left in the denominator, the bottom of the fraction? No. So the only thing technically left is 1. But we don't have to write divided by 1. We can leave it as c times c minus 2. Questions on this here? Was this any harder than the previous one? Did it look harder? Yeah. But when we take these step by step, one piece at a time, it makes them easier to work. And that's really the whole thing with Algebra 2. Now, I think we're starting to feel comfortable with these here. It would be good to do a few of them on your own so that working through getting the hang of it. But there's only one more that we're going to cover together in class, and it's this one here. We're going to cover this one here. The x squared plus 3x plus 9. What is the denominator for it? What's the bottom of its fraction? If I put a division bar here, what would be on bottom? What is the only number we can divide by that won't change it? It's not 0, because we can't divide by 0. Because if it's not written for multiplication or division, it's understood to be 1. So really all that's saying is that this here is going to multiply with the x plus 2 only. Because when we just have a monomial or polynomial that doesn't have a denominator bottom of the fraction, it multiplies just with the top. So if it is helpful to write in the 1 divided by 1 over 1 to help you remember that, do it, because that is going to help you remember how these multiply out. Now, looking at our first rational expression, we have x plus 2 over x cubed minus 27, yes? X cubed is a perfect cube. Is 27 a perfect cube? 3 times 3 is 9 times 3 is 27, yes? So we're going to have a linear term and a quadratic. I'm going to leave x squared plus 3x plus 9 alone for now, because there's a good chance it doesn't factor to begin with, and it might be the other part of the difference of perfect cubes. So, guys, let's leave those alone. Now, if we take the cube root of x to the 3rd, we get x. And if we take the cube root of 27, we get 3. So x to the 3rd minus 27 is a difference of perfect cubes. Now our signs are going to be the same. Opposite always end on a positive note. So the same is going to be minus. Opposite is going to be plus. And then we always end on a positive note with plus. So it is definitely looking like those two are going to match up. Now our first terms are going to be x, and we'll have x squared, and then x to the first. Now this is kind of nice for when we plug in our other term 3, because we do have x minus 3 there. In the bigger one, x squared, we don't put a 3 with it. In the middle, we put 3 to the first, which will just be 3 times x. And the last one is 3 squared. We can do 3 squared, yes? 3 squared is 9. Well, did those two end up matching up? Yeah. That's what we have is x plus 2. So we can connect these here. We can put our parentheses around it. But we know for sure that these two here will cancel, leaving us with what? X plus 2 over x minus 3 as our final answer. Questions on this here? Now, we haven't talked too much about restrictions, but again, the restrictions are going to be whatever's going to make the denominators be 0, yes? What's going to make x minus 3 be 0? What minus 3 is 0? 3. 3 minus 3 is? So x cannot be 3. Now, the other one we need to make sure to find values of x that would make it 0 is the x squared plus 3x plus 9. Now, I typed it in here for us, x squared plus 3x plus 9. So we're trying to see what value of x will make it be 0, where it crosses the x-axis. Well, the blue line is that graph. Does it come anywhere near the x-axis? No. So is there any way we can make it be 0? No. So that means that this part of the rational expression can't be 0. It has no restrictions. So not every polynomial in the denominator will have restrictions. Some will, some won't. But that there is our final answer. Questions on this here? And that's it.